So this lecture, I want to look at some more examples, right? See how we can find antiderivatives of some specific functions. Right, so how about this one? The integral of nothing. Right, well, I say that there is something here, right? Remember, we can always do this. We can always think of this as the integral of 1 dx. Okay, now I'd like to make this fit a pattern that we already know, and we can actually do that. Remember, this is the same as the integral of x to the 0 dx. And that's okay. X to the 0, that's 1. And now it looks like a polynomial. So we can use our power rule to do this. Remember what our power rule says. It says increase the exponent by 1 and divide by that new exponent. And of course, tag a constant on. Right, so this left side, 0 plus 1, that's 1. So this is x to the first divided by 1, which is just x. And there you go. There's my antiderivative. Okay, we have some rules, right? Some properties, and this really very closely parallels rules that we have already seen for limits and differentiation. Right? The integral of a constant, I can take that constant, pull it out front, right? See, it ended up right here, and just worry about the part that actually has the variables in it. Exact same thing we did before with limits and derivatives. Right, and here we got another rule. Again, this closely mirrors what we've seen already. The integral of a sum, you can split up and just do the integral of the parts. Right, now, you notice a rule we don't have here. The integral is, because I want to let you know what not to do as well. The integral of the product of two functions is not equal to the product of the individual integrals. Just like with derivatives, we need a special rule to handle products, right? And we're going to have some special rules for integration that do some similar things. So let's look at some examples. I got this thing, right? I want to know what is the integral of 5x to the 4th dx. Okay, well, first thing I'm going to do, I'm going to use my first rule from the previous slide. I'm going to bring this 5 out in front so I kind of don't have to worry about it. This is 5 integral x to the 4th dx. And now I know what to do. I got the integral of a monomial. Apply your rules. Apply the power rule. I'm going to leave this 5 out in front. Increase the exponent by 1. Divide by the new exponent. 4 plus 1 down here, that's 5, right? So that's just going to cancel. And all that's left is x to the 5th. And now you see, I told you, it is so easy to do. This is the step where I should have slipped that constant in. Right? Always going to have that plus a constant at the end. All right, so you can take a look at this one if you like. Give this a try. See what you come up with. Then we'll come back and we'll go through it together. All right, so I'm going to write this out in great detail. If you did not go into this level of detail, you skipped a few things, that's fine. I'm only doing it this deep into it because it's still very new. All right, so first thing I'm going to do is I'm going to use that second rule and split this up. 6x to the 3rd minus 2x squared minus 4. All right, now I'm going to use rule number 1. I'm going to pull these constants out in front. This is 6 integral of x to the 3rd minus 2 integral of x squared minus 4 integral of dx. And now we can apply our power rule. Right? This is 6 x to the 4th over 4 minus 2 x to the 3rd over 3 minus 4. Remember, we actually talked about this one before, right? The integral of dx is just x. And now I just got some cleanup to do. Reduce the fractions. This is 3/2 x to the 4th minus 2/3 x to the 3rd minus 4x. One of the nice things about integration, right? It's super easy to check your work. Take this, differentiate it, right? Find the derivative. You should end up right back up here where we started. Okay, so how about trig functions? Right? How about trig functions? How would we integrate this thing? Well, thing sine. And this is I hate to tell you this, but this is kind of how integration works. Integration is much less formula based than differentiation is. Right? A lot of the time when we're looking to find an integral, you just kind of think, okay, yeah, this function. Right? You're kind of running through functions in your head saying, okay, what works? Well, the derivative of the cosine is the sine, right? So I'm thinking maybe cap f of x equals cosine. Well, if you check this out, f prime is minus sine of x, which is not what I have. So we've got a little sine issue here, right? But I can fix this. Again, this is kind of how integration works a lot of the time, right? I can fix this. If I put a minus sign in front of that cosine, then the derivative becomes minus sine of x, which is the sine of x. And now we're back where we started. So this is my answer, only don't forget, right, we need to tack that constant on. Okay, so now we've got a few examples under our belt, and we've got a nice rule that we can use, right? Because now we know how to find the antiderivative of any polynomial, which is nice. In the next lecture, we're going to talk about another method for finding antiderivatives. It's called integration by substitution.